Today, I'm pleased to introduce today's session, ASIMOV Enterprise RAG at Dialog Axiata, which is Sri Lanka's leading telecommunication provider. And our guest speakers, Dumindu, Adita, and Nandula. So they will talk about a novel initiative which leverage Retrieval-Augmented Generation, or usually known as RAG, to provide precise domain-specific assistance to telecommunication engineers and technicians. So Dumindu holds a Bachelor of Science in Electronic and Telecommunication Engineering from General Sir John Kotelava Defense University, which is quite a mouthful, and a Master's in Big Data Analytics from Robert Gordon University in the UK. He started his career with Dialog in 2014 as an intern and then transitioned to the permanent team in 2016 as a senior executive in product development. Currently, he's serving as the lead engineer in the network analytics and automation, and his expertise spans across data science, AI and machine learning, big data analytics, cloud engineering, and networking. Adita is a graduate of General Sir John Kotelava Defense University as well. He's holding a Bachelor in Science in Computer Science, Bachelor of Science in Computer Science, sorry. He began his journey with Dialog as an intern in 2021 and has since advanced to the role of senior executive in network analytics and automation. He's also a specialist in data science and AI and machine learning. He also has a pronounced proficiency in data engineering. And finally, we have Nandula, which is an alumnus of the General Sir John Kotelava Defense University, where he had his Bachelor of Science in Electronic and Telecommunication Engineering. He started his career at Dialog as an intern in 2019, and then he progressed to a senior executive in product development. He's currently serving as a senior data scientist in network analytics and automation. And his areas of specialization include data science, AI, machine learning, and geographic information system. Outside of work, he volunteers in public relations and communication roles. Welcome, everyone. And the stage is yours. You can share your screen.
Thank you very much, Stephen. Hope I am audible. Let me share my screen. Hope everyone can see my screen.
Yes.
Yeah. So thank you very much. Won't go long into introductions as Stephen has already done that for us. So welcome everyone. Thank you for attending this session, and thank you to Zilis for inviting us to conduct this session. So I'll get straight into it. So a bit about what we hope to cover today. So we'll start off with a brief introduction to who we are at Dialog Axiata, as well as ASIMOV about the project. Then we will do a deep dive into ASIMOV's architecture and functionality. Then we will also specifically talk about why we selected Milvus as the vector database of choice for this product, and also the future roadmap that we have in plan for ASIMOV. So just a quick overview of who we are. We are Dialog Axiata. We are part of Axiata Group Berhad. Currently, we are Sri Lanka's largest quad-plate connectivity providers, and we serve over 17 million customers island-wide. And then we provide services in mobile telephony, fixed telephony, digital television, international services, digital finance, and enterprise services. Dialog was incorporated in 1993, so we've had over 30 years of service. And throughout those years, we've spearheaded technology first in South Asia and Sri Lanka, which includes South Asia's first 2G, first 3G, first 4G, and first 5G trial network, and which is soon to be commercially deployed. We are also Sri Lanka's largest foreign direct investor, with investments totaling $3.25 billion US. And also, Dialog has, throughout the years, won multiple accolades, including 6 global mobile awards. We've been the telecommunications brand of the year for 13 years running, Sri Lanka's most valuable brand for 5 years running. And as of the latest Open Signal country report, we have the best overall experience, coverage, and consistency across the board. So that's just a brief introduction to who we are and a brief introduction about Dialog. So before I go into what ASIMOV is, for the benefit of those of you who are new to the concept of RAG, or Retrieval-Augmented Generation, I'll just have a quick breakdown of what RAG is. So the first essential part of RAG is embedding knowledge that is in the form of text data into an n-dimensional vector space. So basically a mathematical representation of that text data. And it's represented in this n-dimensional vector data, in this n-dimensional vector space, such that more related data falls close to each other in that vector space. So then in the retrieval step, what happens is we embed an input, which in our case would be a question, with the exact same embedding model that we embedded initial knowledge with, and then what would happen is once that question is also vectorized, then it can retrieve relevant chunks of information, and then those retrieved information then can be passed into a generative model, which in our case is a transform model or GPT, to generate the output that we need. So that's just a very brief overview of what RAG or Retrieval-Augmented Generation is. So to introduce ASIMOV and our motivations for building this product. So when it comes to, so we're all from Dialog's group technology, which is Dialog's engineering arm. And when it comes to our engineering staff, they tackle a very vast area, segregated by various spheres of expertise. So the telco engineering domain consists of access network, core network, telecommunications infrastructure, power and energy. So it's a very wide area, and then the amount of information and documentation that's there, it can either be general information or very product or system specific information. All of that is used on a daily basis throughout the course of our staff's work here. So what we aim to do with ASIMOV is to one, provide a centralized and secure knowledge base, so that all the resources, all the documentation, everything is stored in a centralized, secure place. And then where we provide compartmentalized access, so we provide access to that knowledge to each person based on the sensitivity levels that they have access to on a need-to-know basis, as well as reduce the amount of the time taken and enhance the efficiency when it comes to their day-to-day tasks. Basically, to reduce the amount of time they spend referencing different sources of information, so that they can find quick and easy answers to their queries that arise in their day-to-day work. So that is basically our objective here with ASIMOV. So that is just a bit about our intentions and our motivations when it comes to building ASIMOV. So next, to dive into the meat of ASIMOV and to go behind the scenes, I would like to invite Dumidu to take on the stage.
Okay. Thanks, Nandula, for that great intro into what ASIMOV is. So as Nandula mentioned, ASIMOV has a lot of functionality, so it caters to the entire engineering staff at Dialog. So we, in order to do this, we need to understand how it works. So the ASIMOV comprises of four main components: the front end, the agent, the vector database, and the LLM or the foundation model. So they are interconnected by the agent. So the agent is the heart of the system. So all of these are built on top of very well known frameworks. So for example, the front end is built on top of Streamlit, the agent is built on top of LangChain, then Milvus is our vector database. So yeah. And OpenAI, we use the OpenAI GPT models as our foundation models. So if we go a step further into this, to see how it works, we can see that the agent comprises of the chain, the retrieval chain. So for the initial flavor of ASIMOV, we used the standard conversational chain developed by the LangChain community. So we built on top of this, and we added our own quick quirks and features into this. So one thing that we did was we expanded on the filter function on the chain, and we used the metadata filtering feature. So we added several metadata fields into our Milvus collection. And from that, we gave the users the ability to filter down to the types of documents in order to improve the function and improve the answers and the responses that the system gives back. And another factor that we can change here and there is the k value. The k value here is the number of chunks. This is critical because when we increase the number of chunks, the responses given back by the LLM are more nuanced or more refined. So but all of these need to be done in a certain way according to a certain guideline. So this is done using the prompt template. So basically, if you have a very simple prompt template, such as so this is not a very simple prompt. This is for medium level or average level prompt template. If you have something like this, the system will give a good output. But if you have a well-defined, defined prompt template that gives us precise guidelines on how to respond or how to analyze the chunks, the LLM gives us a very rich or very refined output. So, so we had a special flavor of ASIMOV that we developed. So Nanda will explain that later. That gave us a very refined output. So it was a custom build. So here you can see that we have incorporated the questions, the question, the chat history, and the context. So the question is basically what the user asks from the system. So every time the user asks this question, say what's a radio antenna, something like that, this is where the question goes. Then the chat history is all the previous chats within that session that the user has accumulated. So this grows every time when the chat continues when the user continues to chat with the chatbot. So this can grow as much as possible, but there are certain limits here. The context is the chunks or the data retrieved from the vector database. So I'll go into this later. So all of these are fed into the prompt template and given to the LLM. So we can go on to the next. So the brains of the system. So the brains of the system is the foundation models or the LLMs. So in our pre-release, we went with GPT 3.5. This had a context range of 16,000 tokens. So it was good enough for the pre-release or the initial version of ASIMOV, where we had very small chunks, so around chunks with 1,024 tokens. So it is very small, it is sufficient. But we saw that when we switched to GPT-4 in our launch version, which had a context range of 1,128K tokens, the responses improved. And since GPT-4 is more advanced, the responses were more well-defined, or the refined responses were given out. But this was also okay, but we had a problem with GPT-4 because the responses took a relatively long time to get back to the user, because some prompts went up to like 2 minutes, and this had an impact on our user experience. So as soon as GPT-4o came out, we did a trial and we switched to GPT-4, and the user experience is really good now, because now on average we get around 20 seconds per response. And another thing that we did was we went with Azure OpenAI service. The main reason for this is the privacy clauses, because Azure ensures the prompts that we send to OpenAI, the LLM, the OpenAI service are not recorded or used for retraining their models. So this is a big concern for us because we always wanted to keep the chunks or the documents confidential, because most of the documents that are stored in our vector database are company confidential, sometimes division confidential. So we wanted to keep everything safe. This is also another reason why we went with Mirror. So Aditya will go in depth about this later. So if you come to the next one, yeah. Okay, so another factor that we had to think about was the embedding model. So we saw that, so in general, we went with all min, which is one of like the generally well-performing models. It has been performing well for a long time. So we use that for the general purpose documents. So it gave us really good responses from the technical documents, the instruction documents, and even business documents. So it was good enough for us. But we saw that when we changed the embedding model to something like by or follow IR, the performance changed. The responses became more refined because the vector space changed, and the model was able to pick up more attributes of the text. So we wanted to have the ability to switch between embedding models or the vectors. So this is another thing that we really needed. Then yeah, so to add to this, we saw that when we increase the size of the chunks and the overlaps of the chunks, the responses became more refined. So we experimented a lot with this, and we came to a general norm to limit the chunk sizes and the overlaps to a certain amount. So yeah, and the front end. So front end, as I mentioned, it's built on top of Streamlit. So Streamlit is a very easy framework to work with. But we had to set up some workarounds for certain things like integrating Azure AD into the Streamlit framework, but it worked for us. So the entire Streamlit frontend is not just a chat interface. So we gave the chatbot additional functionality like the filters I mentioned earlier. So the users can select the domains, the subdomains, the vendors, etc., and do all sorts of filtering. So that gives the user a lot of functionality there. Then, so this is the metadata filtering. Then we gave the users the ability to see the most relevant chunk or the most relevant text that is useful for them. So this is a really good this is a really big plus point for the front end users. Then another thing that we did is we gave them the ability to view the most relevant chunks also. So if they wanted to go to the document and review it with the relevant pages, we give them that functionality as well. So the process, so as I mentioned, this is so it's not a very straightforward process. So when the user prompts the question onto the front end, it goes to the LangChain agent. From the LangChain agent, as Nandula mentioned earlier, the question is converted into the vector space, and the nearest 10 or X number of vectors are retrieved from the vector DB. So in this case, Milvus, and it's sent to the OpenAI service. From that, we get the response. So this is the general flow for ASIMOV. But we are in the process of building a custom chain that give us more freedom to change the flow a bit, because we have some interesting stuff coming down the pipeline. So Nandala will go through that also later on. Right. So, and another thing that we wanted to do is give the users the ability or the freedom to upload their own documents and query the documents. So, because normally, if normally the technical team or the technical staff, they keep getting updated documents or new technical manuals and 3GPP releases, for example. So they always need to have the ability to load this onto ASIMOV and always get the latest information. So for this, we developed a separate front end for users to upload the data depending on the specific vendors or the domains and the subdomains, and they can query the relevant information from these specific documents as well. So this gave the users a lot of freedom. Yeah. So this is the general flow for the front end the document loading front end. So when the document is loaded, there's a separate ETL module in the back end which takes in the document. Then it runs the ETL module flow by breaking the document into separate chunks. Then it runs it through the embedding model and loads it onto the vector database. So yeah, so that's the general in-depth architecture and the flow of ASIMOV. So I think Aditya will take us through why we went with Milvus, and we have some really good reasons as to why. So Aditya, you can take over.
Right. Thank you, Domingo. Thank you everyone for being here. So we knew going into this project that we would require a scalable and quite flexible set of solutions to implement our idea into this. So it started off small, but we knew it could become a large scale project because it soon caught the traction of the higher management and everyone who heard about it. So keeping all that in mind, we were searching for some specific requirements, especially to scale the database and everything regarding to that. So Milvus came with with a lot of features, and I'll take you through some of the features that caught our eye. So Milvus supports multiple embeddings. That's the main feature. So as Dumidu explained before, we've tried out all min and by embedding and several other embeddings. And Milvus supports all of that, and it includes all the necessary APIs and SDKs, so LangChain support and Python Milvus connectors. So the transition into including it into one of our on-prem servers and getting it built up and running was quite convenient when compared with some of the other available databases. So Milvus provides flexible hosting capabilities, mostly on-prem and cloud hosting capabilities. So what our specific requirement was that we do not share our data with the outside. So we needed to have the database included in one of our on-prem servers. So Milvus was a good contender for that, along with other databases such as Chroma and BV8. So I'll get into more details on.
Oh. Hey, it looks like you crashed.
Right. So
Hey.
Milvus supports
Okay,
dynamic node allocation. So what that does is.
No, he crashed again. Okay. Now we can see you again.
Oh, sorry. I think I got disconnected.
Sorry, everyone. Technical problem. You're
sorry
back
about
now.
that. Can I continue from? Can I get back to where I was? Or?
Yes. You were mentioning VV8 and Chroma DB and everything, and then you were like starting, so you can start again from here.
All right. So Milvus was a good contender for the on-prem deployable vector databases, and So other key features include distributed architecture and partitioning, which is included in Milvus. So what dynamic node allocation does is, with the increase of the workload, and that is to say the size of the databases and the API calls and the access points, everything, when it's being scaled up, Milvus would handle this dynamically, and it's quite smooth, and the load is balanced. So there's very little manual intervention involved. Milvus does all that for you. And there's another key feature that is included, which is partitioning. So with the inclusion of partitioning, we are able to minimize and increase the efficiency of the memory utilization. We can partition based onto a specific use case. And what the partitions does is it makes so that the entire data set does not need to be retrieved, and just a specific partition will be accessed and loaded into memory. So in our use case, what we've done is partition through either vendor or some of the filters that you saw in the previous slides with the UI. So based on the partitioning there, data is accessed. So those are some of the features that caught our eye, but the key features why we chose Milvus over other contenders were these specific points. So it's first and foremost, it's open source and it has great community support. I mean, we found out we got invited into this webinar, which is saying something, and Nanduro was contacted on social media by the Milvus team when trying to query some of our questions. And so it's great community support, even online forums and all that. And the other feature was on-prem deployment. So this was one of our key requirements where we needed to keep our data within our organization and not hand it over to other organizations. So this came with certain limitations because the databases were still evolving and it was getting to a good stable level, and there were lots of competitors out there that were performing really well. But so we've tested out mostly Chroma DB, but upon testing we found that Milvus had higher queries per second, and the data backup and migration support was much better. So it performed much better and had lower latencies with higher precision when it comes to querying data. So there's another key feature that is the hybrid search, which involves querying data other than the embedded data. So once, as you saw in the previous UI, the GIF that you also, we can filter out specific sets of documents, or we can apply certain filters. So what the filters would do is direct the RAG towards a specific set of documents. So we can provide a more fine-tuned output towards the model. And the other important factor was when it comes to scaling, we knew that we would need to increase the data sets and the number of users and everything with regards to that. And the dynamic node allocation with Milvus has provided us pretty much everything we need to handle the loads. Okay, I think that sums it up for why we chose Milvus over the other competitors out there. Thank you.
Yeah, so thank you, Aditya. So basically that was a breakdown as to why we selected Milvus as our vector database for this project. So I'll go through some of what's next in store for ASIMOV. So one of the things that we are currently working on is expanding this into further domains. While we were working with our technical staff at engineering, we also saw the potential to expand this into other use cases throughout the company. One of the most recent examples is we were able to work with basically we were able to develop a custom flavor of ASIMOV for our corporate planning team, so that helped them when it comes to preparing certain documents for Dialog's annual general meeting, which happened recently. There are use cases like that that provides potential. Expanding into further domains like corporate planning, like regulatory, this is in the sites for ASIMOV. And speaking of that, we will also then create a repository of tailored prompt templates for each use case. And that will help us basically tailor the experience and to improve the LLM's response when it comes to each specific use case. So establishing that repository of prompt templates for each use case is something that we have in the pipeline. And also, so when it comes to our technical documentation, there's a lot of graphs, different diagrams, things like that. So we will be leveraging GPT-4o's multimodal capabilities for much richer document loading, where we get GPT-4o to provide descriptions of image-based information. So that we'll have much richer context there when it comes to the documents that we load into Milvus. So that is also another thing that we are looking at. And also to enable chat with data capabilities. This is not necessarily RAG, but it's an area that we saw has potential. So we will provide connectivity with our internal network configuration, as well as performance databases, as well as crowdsourced intelligence databases, such as those provided by OpenSignal, Meta, so that we would have much greater functionality when it comes to ASIMOV and what it can provide our engineers with. Yeah, so that is basically a quick look at ASIMOV. So if we have any questions, we'd be glad to take them. Stephen.
Ooh, thank you very much for the presentation. It was really, really cool to hear about it. I don't know if anyone that is attending has a question. Feel free to write them in the chat. Otherwise, I have some questions myself, so I can maybe start with those. Then we'll see. So, first one is that I have is like, what the scale you're facing from at the moment? Like, for how many people are using your RAG system?
So at the moment, it's just the engineering staff. So the core engineering staff that comprises of the planning team, who they're the guys who actually use it a lot. So that's around 50 odd people. So they use it, and so we see that so as Nandal mentioned, we worked really close with these teams to develop the prompt templates and to improve the responses. So they had a hand in like refining the outputs. So that got them interested in the system a lot. So they are using it on a daily basis.
Okay, cool. And maybe a follow-up question that I have with that. So do you have, maybe can you share, I don't know if you can share, but like how many vectors do you have in Milvus at the moment, approximately?
Vectors, I think Aditya can give us a good idea of that.
Maybe you can't share, I don't know.
Number of vectors we can, but we can't give you the details on the content of the.
No worries.
So I can comment on that. We have 1.7 million right now, but it's increasing with each day. We are including more and more documents and in different domains, so technical and corporate um, documents. So we are planning to include images and other multimodal requiring documents as another dimension. So it's just going to keep going up from there. But right now we are around like 1.72 million.
Okay. Okay, cool. Thank you. And then we have a question. Does Milvus support higher availability? I don't know if you guys want to answer this one, otherwise I can. But yes, we do. We do support. I'll take this one. We do support higher availability. Yes, we do. And then we also have a cloud offering which has high availability as well. It's 99.99% as well. So yes. And then I have another question maybe. So like maybe it's related more to the future. So, like at the moment, people are talking about RAG, but then there's also like what we call advanced RAG. So is it something that you're like thinking of like checking out, like maybe agents or, like splitting your questions, like maybe your user asking one very long question. So maybe you want to split the question into multiple ones. Is it something that you're like checking out at the moment?
So generally when it comes to our users, they have a lot of follow-up questions. So
Okay.
the chat history function and the chat history helped us a lot to improve the answers. But as you mentioned, the advanced RAG. So I think yesterday we came across a new paper called Raft. I think Nandula can explain a bit about that.
Yeah. So something that we looked into, we were looking into yesterday, was retrieval augmented fine tuning. So, so something that we want to do is, with time, also implement user feedback.
Okay.
So that with time, we will have a good collection of responses and how good and how relevant those responses were for the users. So what we can then use is we can go for a hybrid RAG plus fine-tuned model.
Okay.
Where we can use the output, the feedback that we get from the users, to fine-tune GPT, to basically make it more accurate. And Raft that Dumindu was mentioning, retrieval augmented fine-tuning, it's a fairly new concept. Which involves training, fine-tuning the LLM with relevant documents as well as distracted documents. And basically, we teach the LLM to when chunks are provided to it, to only take in the relevant information. So that is also something interesting that we were looking at yesterday. So yeah, so things like that we hope to implement in the future. Yeah.
Okay, cool. Thank you.
To
Yeah,
add to
perfect.
that, so this with Raft, I think we'll be able to reduce the reliance on the embedding model, because that's a critical part of the RAG system.
Yeah.
So we need to have a top-notch embedding model to get the top-notch answers. But with Raft, we can rely less on the embedding model and go give that complexity or that intelligence to the LLM. So from that, we can get a better response.
Oh, yeah. Yeah, I mean, they're very crucial. Embedding models make big difference usually, like in your results. Okay, cool. Let me check. I don't think we have any more questions. So in that case, I'm going to say thank you to you. Thank you for the presentation. It was very informative. The recording will be shared online. So no worries if you missed some part of it. Feel free to check out our webpage as well. So it's milvus.io. Check us out on GitHub as well directly. And thank you again to Dialog as well for like first writing the blog post. That's how we saw them in the first place, sharing their knowledge. And then, yeah, I'll see you in the next time. Have a lovely morning, day, evening. Thank you again, you guys, for giving a talk here. Have a lovely evening on your side because it's getting late. So thank you.
Thank you, Stephen. Thank you.